Namaskar, my dear friends. Let us talk about MOSFET selection criteria. So, as you know, MOSFET selection has become very crucial component, very crucial part for a circuit designer. So, what is the main reason for this is because of any switching application, MOSFET is needed or either transistor is required, right? So, whether it is a onboard charger or EV application or automotive application or even a simple power supply, path to provide, so there are a lot of high power application, low power application where you will be requiring either to select a P channel MOSFET or N channel MOSFET. So as you can see, P channel MOSFET has the arrow outward and N channel MOSFET has the arrow inward. So I am not worried about how the symbol looks like. However, we will be dealing with various parameters that we need to take care of while designing or while selecting the MOSFET, right? So that you can have a better design, the one of the best design in your industry, because all these MOSFETs will be used in such an applications which will be running for, let's say, 5 years, 10 years in the industries. And you must understand a MOSFET component should be such a suitable component so that it does not go into obsolete phase or something like that, right? So as you can see, based on the package wise, we have various packages like SOT23 package, this one, we have SC70 package. So for low power applications, these are one of the best suitable or like most popular packages that is being used. Even we have a VSON package or WSON package for very small, size, but these are SOT packages, right? I mean SMD packages. However, they have better thermal capabilities and everything. Similar to that, we have VSON package in this kind where we have little bit higher thermal power capabilities. And if you go ahead with power MOSFETs, this can also be used, as well as this is the one which is having, dominating the market. TO220 type and other types are also there. Let me show it to you. We have DD pack, or this is also called as TO263 package. This is another view of TO263. We have TO220 package, TO247 package. As I told you, for lower power application, we have SOT23 package, which is the most popular package that you can think of. Okay. So now what we will do is we will try to list out all the parameters that you need to go ahead and see, right? So let us start with first one. So very first one that you have to think of is the manufacturer that you are going to choose. However, based on the parameter that you are going to specify, all the specifications, there are various manufacturers that will match your specified applications, right? So let me talk about what are the manufacturers, popular manufacturers or trusted manufacturers that can be think of. So if you can see, we have, let us say, few of them I have listed. There will be many more compared to, listed here. So I have listed few of them, like Microchip is there. We have Texas Instruments. We have ST Microelectronics. We have Little Fuse, which has acquired IXYS. So Little Fuse is the one which is going to give you various, MOSFETs for high power applications, as well as, ROM semiconductor also gives you lot of MOSFETs for high power application. Visa is one of the most popular company. Infineon, nothing to say, like we have lot of MOSFETs available with Infineon on semi. So listing out for power upside applications, we have Little Fuse, ROM, Visa, Infineon, OnSemi. Okay. Then as you can see, I have listed here twice, so I can delete here. Okay. So Visa is here, Diode is here. We have Renesas, we have Taiwan Semiconductor, Nexperia is there. So there are various components from Nexperia which can be used for automotive applications as well as normal industrial and appliances applications. Okay. Coming back to the other parameters. So as you can see, once you select a part, you will be having a manufacturer part number that we will be discussing later. So once you make a suitable of all the specifications, then you will find a part number that we will discuss later on. Similar to that description. Coming back to the technology. So these days technology, we have like normal silicon MOSFET is there, then metal oxide semiconductors are there. Then we have silicon, then silicon carbide is there. We have FinFET, okay, FinFET type, or GaNFET is there. So lot of technology is there. So which technology you want to utilize, you have to first decide based on the advantages that they are offering. So this is what it's called as FET type. So FET type is basically whether it is going to be, like FinFET or something like that, as well as this can also be considered as your channel type, whether it is going to be P channel or N channel. Okay, like I mean P channel or N channel. Then coming back to the one of the important parameter, which is called as drain to source voltage. Okay, so the voltage that it will be capable of to hold between drain and source. Okay, so what is the voltage that you will be applying so that it doesn't, like break down or something like that, it doesn't get spoiled. So this is what you have to think of. Let us say you are going to use for 230 volt application AC, so it will go to around 2, like how much it is, 325 volt DC or something like that. So in that case you may go ahead with VDS of 600 volt capabilities or something like that. Understood? Coming back to the other parameters, so let us say we have continuous drain current. So how much current that you want to go ahead, so that will be called as ID, that is continuous drain current. Here only you will be seeing the pulse drain current. Okay, so ID pulse. So pulse value will be little bit higher compared to the continuous drain current capabilities. Now what is the drive voltage, like how much voltage will be needing at the gate? At the gate, this is my gate, right? So what is the voltage that will be required to switch it on and off? Okay, so this is what is your drive voltage. So drive voltage is very important because low power MOSFETs, they can be driven by your microcontroller pin as well. Whereas to drive the gate of the MOSFET of power MOSFETs or something like that, you may need a gate drivers. Okay, so gate drivers are there. There only you utilize gate drivers or motor drivers and all, where you will be needing a power MOSFET, right? Then another parameter which is very important is RDS on. What is the switch? Once the, like drain to source switches on, what is the resistance that is appearing at this particular place, which is called as RDS on. So once it is on, then there will be a resistance appearing across this, which will be very very minimal in terms of, like milliohms. So this will be like 10 milliohms, 20 milliohms based on the requirement, or even it can go to 1 ohm, 2 ohm, something like that. Okay. Let us go ahead with VGSTH. What is my threshold voltage maximum, or what is my get to source voltage maximum that it can withstand? So you would have seen, like let's say VGS is given as like 20 volt, and VGSTH is maximum, let us say 5 volt. So maximum you have to give 5 volt, and it can withstand 20 volt, something like that. So it can switch on even at, let's say, 2.3 volt or something. But sometimes power MOSFETs, they will be requiring, let us say, 7 to 10 volt requirement. Okay, so that is also there. Now this parameter is important. Why? Because the gate charge, what it happens is how much charge is there. So basically the MOSFET will switch on only when this gate and this is my source. Okay, so and this is it. So between gate to source there will be a capacitance. Okay, so this will get charged, and this is how it switches on. So this is also called as CGS. Okay, CGS. So this gate charge plays an important role to switch it on and off faster. So lower the value, higher the switching speed. Okay, then this is how we have input capacitance and drain to source capacitance. All each and every nodes there will be an capacitance that you can see in the data sheet as well. Now let us talk about what are the delay times. Okay, so we have turn on delay time, turn off delay time. So once your MOSFET actually switches on, so it will take some delay, so that will be called as delay time. Okay, so this is, let us say it is switching on, so this is your, like rise time or T on time. And once switched on, after that it will switch off, right? So it will take some time to switch off, so this will be your T off time. Okay, so this is how turn on delay time and turn off delay time. Similar to that, we have power dissipation capability across the MOSFET. So MOSFET will have a power dissipation capability. Based on that, it will get heated up. Okay, so you have to calculate that based on the understanding of how much power is being wasted. So P will be basically nothing but V into I. Okay. So what is the voltage drop across the MOSFET and how much continuous drain current is flowing? Okay. So basically this is the MOSFET that is there with you. Let us say drain, source and gate. So the current that is flowing is your IDS, right? So this current into the voltage drop across this MOSFET will determine the power dissipation across this MOSFET, which will cause the case of the MOSFET to get heated up, right? So that may go beyond the temperature that will be withstanding for this MOSFET. Okay. Now let us talk about other parameters. We have operating temperature. So operating temperature can go, let us say, minus 40 degrees centigrade to 125 degrees centigrade, or even 150 degrees centigrade, or 175 degrees centigrade. Okay. So based on your requirement, you have to choose the temperature range of the MOSFET where you are using, right? So basically, it depends on the application. Let's say if you are using in automotive application, you would like to go ahead with highest temperature ranges, right? Next parameters comes up is mounting type or package type. So basically mounting type, whether you need to have SMD package, that is surface mount package, or TH package like through hole package. Okay. And package type based on the power dissipation capability, either you can go ahead with a smaller package or the bigger package. Okay. So as I showed you the pictures of TO220 package, TO263 package, all those are big power MOSFETs kind of thing. And a smaller package you can go ahead with WSON package or SOT package, SC70 package, something like that. Since you are using this MOSFETs for some industrial applications or automotive applications or something like that, you must consider that all the MOSFETs must be RoHS compliant. Okay. So this is one of the criteria to suit for your EMIMC, like compliance or CE markings and all. Now let us see other parameters is we have product status. So product status, as you are selecting the MOSFET, it must be active state, right? It must be on the in the market or on the shelf, because manufacturer will declare the MOSFET that you are going to select may be there in the market for next 10 years. So there are various applications like Silicon Experts is there, and some other, even DigiKey and Mouser are giving the status of the product that you are going to choose. So they may be having lifetime of, let's say, 10 years, 20 years, 30 years, something like that. So you must make sure the product that you are selecting must not be obsolete already or end of life phase. Coming back to thermal dissipation, so we have like junction to ambient temperature resistance, and like junction to case resistance. So this is the one which will be utilized to calculate what is the temperature rise across the MOSFET, right? So the MOSFET will be having a temperature rise or maybe heating up. So what is the temperature that is going to reach? That will be decided based on this theta JA parameters. Okay. All right, so then you can see datasheet for detailed view of MOSFETs. So you can see a detailed understanding of MOSFETs from the datasheet, because datasheet actually captures almost all the data that is required for your selection requirement. All right. So what we'll do is, as you have seen lot of like MOSFETs pictures that I have showed you, like SOT20 pack, SOT23 package or SC package or TSOP package. We have WSON package and all. Then we have TO220 package, TO247 packages, and TO263 package, and so many packages that I have showed it to you. So what we'll do is, in next few minutes, we'll try to spend some time on a data sheet and understand what are the parameters that we need to look into. All right. So let us open one of the data sheet. Any data sheet you can open. I am going to select one of the MOSFETs, automotive qualified MOSFETs from Little Fuse. So let us open. So as you can see from the first page itself, you will be seeing that we have MOSFET part number. We have 650 volt capabilities with 100 ohms of RDS on, and it is having X2 class hyper FET power MOSFET, and it is having N channel enhancement mode. Okay. So as you can see, a little bit of features is given already here, like it is international standard package, avalanche rated. We have low RDS on and low get charge. We have a lot of benefits, so if you want you can go ahead with that as well. coming back to the application part, so this is most important for any datasheet that is there, because these days all the manufacturers of MOSFETs or any electronics component, they are giving the target applications. So you can see it can be used in your SMPS or resonant mode power supplies. We have DC-DC converters, we have PFC circuits, then we have AC-DC motor drivers and robotics, servo controls. So many applications can be utilized. You can see we have pin diagrams, so like GDS, that is gate, drain and source, and this is the N channel MOSFET symbol that you can see. So the arrow is inward, it is indicating this is N channel MOSFET. All right. Coming back to the other parts, we have the maximum rating that you can have. So as you can see, we have VDS, that is going to be 650 volt. We have VGS, that is gate to source voltage, which is going to be plus minus 30 volt, right? So for low power MOSFETs, it will be around plus minus 20 volt. However, this is power MOSFET. That's the reason it is having bigger capability. All right. Now, what is the drain current that it can withstand? So it can withstand up to 34 amperes continuous current. We have peak current capability as well, which will be little bit higher, that is 40 amperes. Now the other parameters that you can see, we have avalanche current, that is going to be 7 ampere, and we have, like, let us talk about power dissipation. So power dissipation, you can see we have 540 watts, so it can withstand up to 540 watts. We have temperature range, so temperature range, it can go ahead with up to -50 to 150 degrees centigrade. Okay, so -50 to 150 degrees centigrade it can withstand very easily. Okay, similar to that, other parameters are there. Okay. Next we will talk about thermal characteristics. So in thermal characteristic, you can see it is 0.23 Kelvin per watt. It means for 1 watt of power dissipation, it will be increasing by 0.23 Kelvin temperature, or like since it is a relative temperature, so it can be considered as degree centigrade as well. Okay. Similar to that, we have thermal resistance case to heat sink. So case to heat sink, typically it is 0.50. Okay. Similar to that, we can see more electrical characteristics. So breakdown source voltage, it is having 650 volt. So this is the one which we used to see, because other one what we saw was maximum, absolute maximum. Now this is recommended. Okay. So the threshold voltage requirement will be minimum 3.5, maximum 5 volt. So between these two, you can like apply and switch it on. Okay. So you have IDS current, that is like 10 microampere, that will be your leakage current, and RDS on, it will be maximum 100 milliohms. So 100 milliohms will be maximum RDS on that will be available. Now talking about dynamic characteristics. So dynamic characteristics, we have like transconductance and all those things. Let us forget those. We will talk about input capacitance. So input capacitance, let us say 3200 picofarad, and we have output capacitance, that is 1560 picofarad. So this will be the ones which will be determining what will be the charging time and discharging time, or switching on, switching off delay times. Okay. Similar to that, total gate charges is here, which is having 64 nanocoulombs. Okay. Now, as I told you, we have a gate charge, charges at each junction. So we have gate to source charge, gate to drain charges. The thing that we have to talk about is turn on delay time. So turn on delay time, you can see we have 38 nanosecond, and turn on delay time, turn off delay time, we have 66 nanosecond. All right. And rise time is 52 nanosecond, and fall time is 31 nanosecond. So you must make sure your application must be meeting these delays. Otherwise, it will like not be suitable applications, not be suitable component. Next, we have source to drain diode characteristics. So as you have seen that the MOSFET looks something like this, right? And you saw that there was a diode between these two, right? Like this was source, this was drain, and this was gate, and this is the diode that is there. So this is having some characteristics. So based on that, like how much current it can withstand. So that is same 34 amperes. Peak current, it can go up to 136 amperes. What is the forward voltage drop? That is 1.4 volt. And similar to that, other parameters are also there. So it is exactly the same diode which is having a simple diode separately if you see. So we have reverse recovery time, reverse recovery charge, and reverse recovery current. All those things are there. Coming back to the characteristics that we should look into. Okay, so while selecting a MOSFET, you must understand what is the characteristic curve, right? So how much voltage, like between drain to source you are applying, that is going to be application voltage. Let us say 200 volt, 300 volt. So that is fine. However, the gate to source voltage that you are applying, right, will be the one which will be determining its switching characteristics. So as you can see, for 5 volt or something, it is still below 0 amperes. Okay, so as my current has to be increased, my VGS has to be increased. So as you can see, around 7 volt or higher, it's showing the good characteristics. Okay, so you must make sure the gate must get 7 volt or more to have a proper switching characteristics. All right. Now it can be seen here extended manner. So you can see for 10 volt, it shows very nice curve for the switching. Coming back to the other curves, this curve is very important. What happens is, what is the maximum drain current versus case temperature? So as you can see, till around like 30 degrees centigrade or 35 degrees centigrade, you can see my current capability is not changing. It is having around 34 amperes of current, right? But as soon as it reaches more than 35 degrees centigrade, as you can see, as the temperature is increasing, my current capability is reducing. All right, so you must make sure this curve in action. So if your temperature is going to increase more than that, your current capability will reduce. So you must make sure your application is going to suit that. All right, next is we have switching characteristics. So this is the switching curve. So let us say we have gate charge and we have VGS. So VGS, what happens is, it start as you start applying the voltage. As you start applying the voltage, the gate charge starts charging, right? And then it reaches to a location where it holds for some time, and then again it starts switching. So this is how the gate switching curve happens. So this is also very important. So this is what like given in the data sheet of any manufacturer's data sheet that you will look into. All right, and these are mechanical data that you have to look into, like what is the length, width, and everything. Let's take an example from Vijay. Vijay also shows same thing. You can see we have the N channel MOSFET symbol. This is the TO247 package, and we have lot of features. Then we have application like automotive onboard charger, DC-DC application. If you want to see the part number, this is the part number of this particular Vijay, like enhancement type MOSFET. And if you see the product summary and all, so what is the VDS, what is the current capabilities, and all those things are given very nicely. So alright guys, hope you have now a very good understanding about how to select the MOSFET and what are the parameters that you need to look into while selecting the MOSFET. So if you do have any questions regarding a particular application for your design, whether it is a automotive application or industrial application or home appliances or anything for low power or high power application, you can reach out to us or you can inquire with us like how to select the MOSFET for your particular design requirement, or any electronics component requirement you have to have a like a understanding of how to go ahead with selection of a component with better longevity and better capabilities. So this is the best way to go ahead and select your components. Thank you guys.